It's 174 petawatts of solar that hits our Earth every single day. It's just an amazing amount of power, and this is one way to start harnessing some of that power and use it for transportation. I'm Mike Tinsky, and I'm the Director of Vehicle Electrification and Infrastructure at Ford Motor Company. Solar, which is, we call it PV or photovoltaic, has not only increased in its efficiency, but it's now gotten to a point where it's beginning to show economic viability, that we can actually power our vehicles, our plug-in hybrids like the C-Max Energi, on solar. In this particular case, we've taken about 1.5 square meters of solar PV and put it on top of our C-Max Energi, and it's called the C-Max Solar Energy Concept. Now, alone, that solar will only generate about 300 watts of power, which is not enough to fully recharge the battery in one day. But if you take this vehicle and you couple it with what we call a solar concentrator, just basically being a lens that can magnify the solar energy, and what you end up with is a combination of vehicle plus infrastructure that can essentially recharge that C-Max Energi battery from 100% from solar energy. We're proposing a static canopy of nothing more than what we call Fresnel lens. It's acrylic, so it's a very low-cost canopy. But the vehicle itself, as the sun traverses the sky from east to west, the vehicle will essentially move in the opposite direction and always keep that solar energy concentrated on the roof of the vehicle. So still using the same amount of solar on top of the roof, but getting that magnification that comes from low-cost infrastructure, such as the concentrator that we've been looking at. It's an innovative way to find a low-cost, clean, renewable way of recharging the C-Max Energi.
SunPower cells are fundamentally different than conventional cells. You'll notice all the metal is on the back, and this allows us to use that metal on the back as the foundational support of the cell. It means we can also make the silicon much thinner, meaning that it is actually allowed to flex a little bit. And as you can see, we've got a curved glass surface we've got to match up to here. So the ability to bend is very good. Additionally, we have much higher power density than conventional cells. So that means out of the same space-constrained area, we can actually harvest 50% more energy than conventional cells could. I'm actually quite excited to work on this project because when I was a kid, all we would ever see when you mixed solar and cars was these small, very impractical cars that flew across the Australian desert. This project is extremely exciting because here we're actually taking real solar panels and we're adapting them to fit on top of a car. But it's not a lightweight car that's going to fly across the Australian outback. It's an everyday car that we could expect to see in the cities and on the highways.
This solution, where you couple the infrastructure with the solar on the vehicle, essentially isn't reliant on a grid anymore. And so if you're in an area that doesn't have electricity either provided or a very unreliable source of electricity, this concept will still work. It's a freestanding concept. At Ford, we're really concerned about the environment. We're really concerned about sustainability, and this is a concept that could really improve that.